output to carry out joint research work and participate in leading control conferences such as ACC, IFEC, ALCOSC, etc. I now request our chief guest to deliver the address.
Hello, Chief.
So a very good morning to all of you. Yeah, thanks for your reply. And before I start with the talk, so my talk was originally planned for 1.5 hours. I think you have been saved with half an hour, and I will be given only 1 hour time now. Okay. So I would like to thank the organizers for giving me an opportunity to share the kind of experience we have in working with AI area. So we work in the AI area for the past 2 decades, and we have used this AI for plenty of applications. And today I am going to discuss with you how this AI can be used for a smart agriculture. Okay. Today the intention of my talk is like, I hear that you are all final year students. Okay. So even the students who doesn't have much knowledge about the AI, I am going to start with the basics, because directly if I touch upon the application of AI, you may not be able to appreciate it. So I am going to have a quick recap of what is AI, and then we will see how AI can be used for agriculture applications. Okay, my talk will only be a kind of overview. Okay, but you can use AI. But now using AI becomes so easy these days, because AI tools are available in different languages. Like you would have come across AI tools in Python, in MATLAB, in LabVIEW. So any software platform, AI tools are available. So now you can make use of the AI tool which is available. So that means there is no need of doing the coding from the scratch onwards. What is required is how to make use of the tool and how to tune the parameters of the tool and how to make it work. That is what is required. So for that, if knowledge on AI is there, it's very easy to develop AI application these days. Let me start with what is AI, okay, and what is going to be covered as a part of this AI. Okay, you would have come across different terminologies, like people talking about data science, data analytics, big data, then process analytics, machine learning, data mining, soft computing, statistical learning. All these terminologies are interchangeable. They all basically mean the same. What is it we try to achieve by using this data analytics methods? Okay, as the name implies, in data analytics or in AI, basically we wanted to handle data. Okay, basically we wanted to analyze the data. Okay, what is it we wanted to do by analyzing the data? Whatever hidden information, the meaningful information which is hidden in the data, that we wanted to extract it. So basically data analytics deal with analytics or analysis of data. Okay, where do we have data available? Data is available everywhere in every application. So we are going to see how information is going to be extracted from the data. The information that is available in the data, that we wanted to extract it. So that is basically our objective. So whatever meaningful information which is hidden in the data, that we wanted to extract it. So from that you wanted to make some kind of predictions, you wanted to make some kind of inferences, you wanted to take some kind of decisions, you wanted to give some kind of a recommendation. So that means for all this AI data analytics method, the input is going to be the data. Okay, you analyze the data and try to come up with some meaningful output. Okay, the meaningful output may be a continuous output. So if it is going to be a continuous output, you say it can be used for modeling or prediction purpose or for regression application. So you can predict. You will all would have come across like weather forecasting, weather prediction, load forecasting to please students. Okay, all that can be done. So based on what has happened in the past, we wanted to predict the future. Okay, based on what has happened. So that means in all these applications, what is lagging is like the mathematical analysis would have been lagging. Okay, so that information is available in the data, but we do not know the mathematics behind the data. But even without knowing the maths, even without knowing the mathematics which is there with the variables which are collected in the form of a data, you wanted to make some meaningful information. So whatever we are doing, it is going to be some kind of a black box approach. So there is a black box for which you wanted to give whatever information data that is available. The box is doing all the processing and is giving you some meaningful output. So the meaningful output may be predicting the future, some kind of a prediction, and you wanted to do some kind of a classification, let's say. So based on the data, you wanted to do some kind of a classification. So these are the interesting applications that you come across in any domain of engineering. So even in agriculture, we are going to see what kind of regression models can be developed using AI, what kind of classification models can be developed using AI for a specific requirement of agriculture. Okay. So in agriculture, again, we all know that what is the challenge in agriculture? We do not have any maths for agriculture area. Agriculture application, there is no mathematical equations. We do not have maths. But there are a lot of data that is available. So we wanted to understand the data and whatever expertise which is there with the human. So that we wanted to translate it to the AI tool. So basically we need some kind of expertise also. So human expertise can be translated in the form of an AI tool. So there are data available, human expertise available. So with the data and human expertise, we wanted to develop a system which can mimic a real human expert. So here we are trying to mimic a real human expert. Okay. So what does a farmer do for an agricultural applications? Okay. He basically observes a lot of information which is distributed in the field. So he just see what is there in the field. Then there is a logic which is running in his mind. Then he is taking certain decisions. He is taking certain actions. So the same human like farmer expert, you wanted to mimic it in AI. So whatever decision which is taken by a farmer, the same decision you want a AI tool also to take. What is the input information that is available with the farmer? He collects a lot of field information. He sees how the field does. So from whatever he is seeing it, whatever data that is collecting from the field, he is taking a lot of decision. What should be the recommendation? Like how much fertilizer to be added? Okay. Is there any disease that with which the crop has been affected? Okay. So all that basically it is a human who is making the decision. That we wanted to automate it in an AI domain. We wanted to automate it. So what we are trying to develop is some kind of a digital twin for a real farmer. So that is what we are aiming at. Okay. So this is basically the requirement. Okay. Now whenever we talk about the data that should be given as an input, the data may be in variety forms. Okay. So the data may come out of some kind of a sensors. The data may come out of like when a farmer is seeing the field, he is trying to capture the information. That is the vision that is getting captured. So that human, whatever he is seeing it, that kind of information also should come to the AI tool. So that means you can use cameras, you can collect lot, whatever the farmer is seeing, the same thing can be seen through a camera also. So you can collect lot of videos, you can collect lot of photos, all that can be given as an input to our AI algorithm. So AI algorithm can receive lot of data which is coming out of the sensors, information which is captured by the cameras based on which you wanted to make certain decisions. Okay. Like initially to develop the AI system, okay, we need some kind of an expert who can label and tell us if this is the input situation, what is the recommendation that farmer will be taking. So that means the expert knowledge. So that is basically called as labeling. So you need to label what is that you want as an output. So like whatever input which goes to the AI system, when the same input is given to an expert farmer, whatever decision that he is taking, is going to be the label for an AI system to be developed. So we need to develop an AI system. So developing an AI system is basically called as training or learning. So you have to make AI learn a particular situation. So once all the possible combinations of input outputs are given to the AI system, from the input output the AI system can learn and it can make an appropriate prediction. So this is basically where think of using AI. So specifically we can think of using AI mainly because we have got plenty of data available with you. There are rich expertise available with the farmers. All the knowledge you wanted to automate it and transfer it to the AI tool. So that's what we are trying to achieve in using AI for an agriculture application. Okay, and we will come across a lot of challenges. What are the challenges which are there for an agriculture application? Why AI is supposed to give some kind of an improvement? What are the different AI tools that can be used for an agriculture application? What are the different use cases where people have used AI in agriculture and they have achieved some kind of a significant benefit out of it? So all that we are going to discuss as a part of this. So this is a small introduction. Okay. Yeah. So what is AI? So in AI or in data analytics, we wanted to process a raw input which is coming to the AI tool, and then we wanted to make some meaningful conclusions or meaningful predictions we wanted to make out of the particular tool. Okay, and so I'll just skip through some of the slides, okay, because we may not have time to cover everything. So whenever we talk about machine learning and AI, what is it we are trying to do? Okay, so basically the application for AI can be a prediction application or it can be a classification application. Like here you will see, okay. Yeah. This is not coming. Okay. So like basically when you talk about AI algorithms, it can be a supervised application or it can be an unsupervised application. So when you see a supervised learning method, as the name implies, if the data is a labeled data, that means for different combinations of input data, if I can specify what is the desired output that I am looking for, what is the target output that I am looking for, that is basically called as a labeled data. Okay. So if the data is a labeled data, so that means you have got all inputs to the AI tool and what is that you want as an output. So that output is going to be given by the expert farmer, okay, who has got a rich expertise. Okay. If you can label the data, then you can use supervised learning method. So that means for each input combinations, I know what is that I am looking for as an output. That is the supervised. And if you do not know the label, you have got only the collection of inputs, but if you wanted to do some kind of a classification or clustering on the inputs, basically you wanted to do some kind of classification on how similar are the inputs. All the similar inputs you wanted to put it into different clusters or different classes. It is basically a classification application. So most of the application will be either a regression application or it can be a classification application. So if it is a regression application, it can be used for predictions. If it is a classification application, you can use it for diagnosis or classification purpose. Okay. So basically, we will train the machine learning algorithm with whatever training data that is available. After it has been successfully trained, you will give all the new inputs, and then the model, the trained model, will give you the predicted output. Okay. And again, like for most of image-based applications, there are a lot of scope for vision-based applications. Okay. Again, in particular, in agriculture, there are a lot of scope for vision-based applications. So whenever you wanted to work on the vision-based application, you need to use deep learning algorithms. There are plenty of deep learning algorithms. In the past decades, people have introduced, researchers have introduced, which gives us a significant improvement in the output. And you can give image as an input for the deep learning algorithm. Okay, and I'm just giving that. So we have, okay, so like earlier, before these deep learning algorithms have been introduced, okay, how people were handling the image data. So they try to give, like here if you see, this is a traditional way, okay, traditional way of developing some kind of a classifier. Okay, so in this case, like if you see, from the image, we will try to do hand graph some of the features from the image. And those features will be given as an input to the trainable classifier, and that trainable classifier will try to classify. And this is an application. So this is an application where you wanted to identify whether the picture is taken in an indoor location or in an outdoor location. So here we see the image where the picture has been taken from an indoor location. So what we see here, from the image, certain hand-grafted features are extracted, which are given as an input to the classifier. There are varieties of ML classifier which you can think of using. For all these classifiers, there are Python codes available, there are apps available, there are MATLAB codes available. So you need to extract certain features using image processing algorithm. Those extracted features you have to apply to a trainable classifier. So this trainable classifier, like for each of the image, you have to say whether the image belongs to an indoor location or an outdoor location. So that is what is basically called as a labeling. Okay. So here is an example where you see the image belongs to an indoor location. So this is the way traditionally we were doing it by hand grafting the features. So that means the image cannot be directly handled by the AI algorithm earlier. The traditional machine learning algorithm cannot handle the image directly as an input because there is too much computation complexity. But with the introduction of this deep learning algorithm, okay, with the introduction of the deep learning algorithm, Like you all would have come across a term like CNN, convolutional neural network, okay, where directly it can directly handle the image. Okay, whatever feature extraction which was happening manually using image processing algorithm by handcrafting, now it can automatically happen by the initial few stages of a CNN algorithm. So that means when image is given as an input, the CNN, few stages of CNN algorithm extract the features from the input image. Okay, like if you see the first stage of a CNN algorithm may extract the low level features, which may be wherever there are some edges, lines present. It can be an edge detection algorithm where you can extract certain edges which are present. Then those low level features will be given as an input in the second stage where the low level features can be converted to mid level features, where we can combine lines and we can identify small objects which are present in that image. Again, mid level images combined together can be converted to high level features. Like again, small parts of the objects, you can combine them and try to identify what are all the objects which are present. Okay, so that means from the image we are trying to get the high level features. Okay, and these high level features will be of reduced dimension. Like if you see the input image may be 1024 by 1024. So that is the complexity of input. But finally, when you do the feature reduction, okay, it may come to maybe like 1000 features. Okay, so these 1000 input features can be easily handled by a trainable classifier. So you can get the corresponding output. So that means the last stage is going to be the supervised stage, and all the initial stages are going to be unsupervised stage. So in the deep learning, the main point is like the extraction of the features will also happen automatically, and then the extracted features will be mapped into the labeled or desired output by the last few stages of the deep learning algorithm. So both feature extraction as well as mapping it with the desired output is happening automatically in a deep learning algorithm. So these deep learning algorithms are going to be completely automated tool, which is a combination of unsupervised and supervised learning algorithm. So that means the development time is going to become very less when we think of using these kind of deep learning algorithms. Okay, and here again, like if you see the image given as an input to the first stage of a deep learning algorithm will try to identify certain edges, and then let's see mid level, those edges are combined together to give you a small part of your object. Then again, like you see, those small parts are combined together to identify some specific objects which are present in that image. So you see here, there are some windows and you have got some bed and there is a fan and there is a small AC, there are certain cupboards. So all that is getting identified as a high level features. So when you have combination of these objects present, that is getting mapped into an indoor image. So similarly, like if you see in an outdoor image, there will be a lot of greenery present. Okay, so by identifying the small portions of the information that is available in the image, you can correlate it with a different output. So you can easily identify whether the image is taken in an indoor location or in an outdoor location. Okay, like here you see the objects getting identified, and then finally you say whether it is an indoor or outdoor. Okay, this is again for text. I'm just keeping it. Okay, I'll just keep this simple because we are running out of time. Okay, so why traditional? Why this is a complexity? Okay, so the traditional artificial neural networks or machine learning algorithm cannot handle the image as such, because if you see the complexity, when we take a color image, it has got 3 channels like RGB, and each of the channel, if it has got 400 by 400 pixels, like if you see the amount of input that is required will be around 4,80,000 inputs need to be given to a traditional artificial neural network. So from this 4,80,000 input, you wanted to take a final decision whether it belongs to an indoor or an outdoor. So the complexity of this architecture, again, if you see, if you consider even one layer in an artificial neural network, which has got, let's say, 4,80,000 neurons, the amount of parameters that need to be trained is going to be approximately 230 billion. Like 4,80,000 by 4,80,000 is the amount of parameters between the input and the first neural network layer, which is called as a hidden layer. Then the hidden layer to the output again 4,80,000 into, like let's say if there are 1,000 outputs in between layer into 1,000 plus 1,000 plus 1. So that means instead of 4,80,000, if you consider 1,000 neurons also, you need around 480 million parameters to be learned by the network, which is going to be too difficult. So basically the conclusion is the traditional artificial neural network cannot directly accept image as an input, because you need, in terms of, even for 400 by 400 pixels, I need around 4,80,000 inputs which need to be accepted. So that is going to be highly computational complex. Learning it is going to be so challenging. So that's why, so there is a very interesting deep learning algorithm which can be used for imaging, that is called as CNN, which is a convolutional neural network. So that's very interesting. We will see how does a convolutional neural network will work. Okay. Basically, like you see, in a convolutional neural network, there is what is called as a filter, or otherwise called as a kernel function. Okay. So there will be a kernel. Okay. You have got an input. You have got an input image, and there is a filter or there is a kernel function. This kernel or filter will move through this image, and it will get convolved with the pixel information which is there. Like here, if you see, this is the input image. When you convert it into corresponding, okay, RGB and corresponding gray levels, each of the gray level will vary from 0 to 255. So it can be converted like a matrix like this. It can be converted like a matrix like this. Then in this matrix, we wanted to perform a convolution operation. That means my filter, I will be just striding through horizontally, moving it horizontally, then move it vertically down. The complete input image is going to be scanned by performing a convolution operation between the filter and the input image. You will see that here. Okay, you see, you will run through like this, scan it like this, perform a convolution operation. So what is a convolution operation like? Well, when we convolve with this typical filter. So this filter coefficients are basically used for detecting the edges which are present in the input image. You see the input image convolved with this particular filter is giving you a convolved image which is nothing but the edges which are present in the input image. Okay. Now what does a convolution operation do? So let's see with one simple example. Okay, how do we get? Okay, like here instead of the image we have taken a 4x4 input. This 4x4 input, which is a small portion of an input image, is going to get converted with a 2x2 filter. The coefficients and filters are W1, W2, W3, W4. So now we wanted to perform a convolution operation, which is a mathematical convolution operation. So what does we do convolution operation? This 4x4 filter, you try to basically have point-to-point multiplication between the input image and the corresponding filter. So that means you get A into W1 plus B into W2 plus E into W3 plus F into W4. That undergoes an activation function to give you H as an output. Okay. Then you will move through the filter. Okay. You will move through the filter. You see you have moved through the filter now. Then you will get the corresponding H2 by convolving the portion of the input image with that particular filter undergoes F to give you the H2. So like that, this was an input image that was convolved with the filter. The convolved image is now the features which are extracted from the input image. Okay. We see here there is a reduction in dimension. The original input image was 4x4. When I convolve it with the 2x2 filter, I get a convolved image which is 3x3. Okay. Now here I am moving through only one pixel. You can move through by 2 pixels also. So if you move through by 2 pixels, it will get reduced to a 2x2 feature map. So that means you are reducing the dimension from 4x4 to 2x2. Okay. So if it is 400 by 400, by convolving with a 2x2 filter, by striding through by 2, you can reduce it to 200 by 200. So that means there is a dimensionality reduction which is happening by performing the convolution operation. So basically we try to convert the image into features by performing a convolution operation. So these are the low-level features. Now again, this low-level feature will be given as an input to the next convolution stage. There again you will convolve with one more filter. So from this low level, from 3x3 it will get reduced to 2x2. From 2x2 it will get reduced to few number of features. So that's how we try to reduce the dimension, extract the features, and then try to get the feature map automatically instead of manually doing it. So number of parameters in this case is only the 4 filter parameters that you have to learn. Okay. I think I just, yeah. So that is about the convolution operation. Then we'll do the pooling operation, which can be a max pool or it can be an average pool. This is also a part of CNN. This is all part of CNN. So again, in a max pool, you will convolve with the 2x2 filter, stride through by 2. You will try to find out for every 2x2 small portion of the image. If you use a max pool, it will be like the output will be whatever maximum value which is there in the first 2x2 pixels, like 1342, maximum is 4. Then 5331, maximum is 5. Then 3101 maximum is 3. Next to 41304 maximum is 4. So this is basically the max pool operation that we try to perform after the convolution in a CNN. Okay. So what is happening in a CNN finally? Okay. Finally, if you see in a CNN. So these are the different stages of your CNN architecture. Okay. For CNN, again, if you wanted to use CNN for your application, there are codes available. You need to specify how many stages are you looking for. What is the size of filter that you are looking for? What are the coefficients? Okay, that only we have to decide. So, like here, if you see, we had an input image. The first stage, whatever you see in light red color, the striped one is a filter or nothing but the kernel, and that is basically the first two stages. Then you perform the dark. Red is the match pool operation that we perform. So we see here there is a first stage which is which filter is 60 by 4, 64 by 64. Then the second stage with 128 by 128, and then the third stage which has got 256 by 256 by 256. Again, the filter can be 2D or 3D. So finally here what we see, we had an image which was 400 by 400 by 3. Finally it got reduced in terms of only thousands of features only. At the end, the dark red last basically means that there are only limited number of features, 1000 features, okay? So image is getting converted to 1000 features, and the last is say those 1000 features you try to map it with the labeled output that you are looking for. So this is what is happening in a CNN, okay? So here you can use it, there we did only classification whether it is an indoor or outdoor. Here you can have many classes, it can be multi-class. You can say whether the picture is taken in a living room or is it in a bedroom or it is in a kitchen or is it in a bathroom or is it in an outdoor location. You can have multiple classes. All this can be done very easily using CNN kind of a deep architecture. So this is just to give you an outline about what is machine learning, what is deep learning. So now, so we have seen some introduction for what is AI, what is machine learning, what can be done using machine learning. Now we are going to see how we are going to use AI as a tool for agriculture applications. Okay. So like as I said, like it can be AI, ML or data science. We wanted to use it for a smart or precision agriculture. We wanted to use it. Okay. Now if you see, what are all the important requirements and what are the challenges that people are facing in the agriculture area? How AI can give some kind of an improvement? What kind of improvement we can aim for? Like if you see, basically we wanted to get most of the research community or the agriculture scientists wanted to have some kind of an improvement in the crop yield. Okay, we wanted to ultimately, finally, we wanted to improve on the crop yield, and we wanted to reduce all the resource consumption. We wanted to reduce. So the water scarcity, we wanted to use reduced water. And if the crop is going to be affected some kind of a disease and if there is a pest, you wanted to identify that. Okay. So ultimately, like if you see the challenges that people are facing, why we wanted to use ML? Okay, because we don't have any mathematical equations for an agriculture application. Everything is available to us only in the form of data, in the form of expertise available with the farmers. So with the current data, with the expertise available, we need to develop a system which can help an inexperienced farmer also. So that's an important requirement. Like if you see why we wanted to use ML, because there are a lot of uncertainties which are associated with agriculture applications. We see here the climatic condition drastically changes, soil conditions keep changing, and environmental parameters are affecting the agriculture area. So much uncertainty is there, and we don't have the mathematics. And geographical region-wise, there are a lot of variations. Region to region, there are a lot of variations. So there is a requirement for customizing it for different regions. Okay, like we say, patient-specific treatment is required. Here, region-specific recommendation is required. So much variation is there with respect to the region. And there are only limited measurements which are possible. We don't have many sensors. For example, people talk about soil quality. We don't have any sensor which can directly give you the soil quality. But you need to have some kind of a offline analysis. You have to take the sample to the lab. They take minimum 3 months time to find out the soil quality and give you some kind of information regarding the soil quality. So that means real-time measurement is not possible for many of the important information which are required for the farmers. They have to spend a lot of time and they have to spend a lot of money in doing all this testing. All these testings are happening offline. Whereas using AI, if you can develop a soft sensor, if you can develop a system which can tell about the soil quality online, real time, immediately, by inserting that I should be able to find out the soil quality. So if you come up with one such soil sensor, which can directly tell you about what is the quality of the soil, that is going to be a real research, which will drastically help the farmers. And as a set of students, okay, we got funding support from Balakamalam Trust, and we have developed one such soil health sensor. Okay, so that sensor AI we have used as a tool based on what are all the parameters which are measured by simple sensors. We are trying to make some kind of an inference about what could be the soil quality. So the soil health of the soil basically depends on how much organic content which is present in the soil. So that when we send it to the lab, they take 3 months time to give us the output. Whereas the same output, very close to that, we are able to get it instantaneously using the sensor that we have developed. So in that we have used AI as a tool. So for that AI tool, whatever available measurements, like what is the NPK values, how much is the moisture content, okay? So nutrient values which are present in the soil. So that is given as an input. So from based on all this input, we are able to say what is going to be the soil health or the soil quality of the soil, texture of the soil. Again, you want a texture of the soil. So using image processing, you can identify the texture of the soil. So there is a big scope for developing sensors for agriculture applications. Okay, and again, like here we see there are only limited measurements possible, but there are decades of experience available with the farmers, which we have not fully utilized it. Okay, and again, the market demand and trend keep changing. Okay, without knowing what is the demand in the market, if a farmer is cultivating a different crop, he is not going to be benefited out of it. So some kind of a market trend analysis is required. And whatever technology that we are developing, that is not reaching out to the farmer. Farmers are unaware of the latest technologies and the solutions that are being proposed. Okay, and one of the statistics says, okay, the CEO of Nurture Firm, he says that out of the 570 million farmers who are there in the worldwide, only 470 of them are only the small farmers. They are only smallholder farmers. Okay, so out of 570 billion, 470 are only poor farmers. They are not aware of the technology. They are not aware of the solution. So our responsibility is we have to take AI to those kind of farmers so that they can get a lot of benefit out of it. Ultimately, ML is going to help the farmers to use the resources effectively and also to have a continuous food production. Okay, and if you see the market statistics, how ML is used for agriculture application. This is again statistics which I have took from the net. Like if you see the estimated compound annual growth rate by 2030 for ML in agriculture area is expected to be 27%. It's going to be growth is going to be 27%. And if you see the cost of plant disease globally, how much is getting affected globally? Around $220 billion money is getting wasted because of the crops getting affected by the diseases. So if we can have a proper disease detection system using AI, and that is going to help the farmer drastically to reduce this particular amount. And IoT is again used for agricultural monitoring, remote monitoring. That means there is no need to go to the field at all. Even from any remote location, the farmer should be able to see the condition of this field. So that technology is going to be in 2025. Now, it's going to be like $4.5 billion. And the smart agriculture market, expected market by 2028 is around 24. Like again, you see 70% of the farmer, they have the proper money to invest on that. And 2/3 are not properly using their technology. More than 50% are not even aware of what kind of solutions are available in the commercially available in the market. So it is our responsibility to take those kind of farmers. Okay. And what are all the challenges? Okay, why people wanted to go for ML for agriculture application? Okay, like if you see, currently we have got low yield, so we wanted to improve on that. So using ML, it is possible to improve on the yield of the crop. Okay, by appropriately designing the irrigation system using again ML, and then identify optimal planting, how the planting need to be done, what kind of crop is recommended for what kind of field, all that can be done based on a lot of data which are available. And again, disease outbreak, okay. You wanted to predict the diseases and earlier warning you wanted to give to the farmers. Then the soil quality is getting degraded, so we need to improve on the soil health and appropriate fertilizer need to be recommended. Soil we need to properly manage it. For all this, AI can play a very big role. And again, water scarcity. So in the presence of water scarcity, how to optimize the irrigation schedule, how to identify efficient utilization of the water, all that ML can play a very good role. And again, climate change, we need to have a lot of predictions. So all predictions can be done beautifully by using AI as a tool. We have to adapt to the changing conditions. So these are all the potential areas where ML can play a significant role in agricultural application. Okay, like specifically if you see, as I said, like you can come up with sensors for soil quality, you can identify the moisture content that is present, or organic compound predictions, carbon predictions you can do, fertilizer recommendation you can do, then crop management, you can say like yield prediction, how the prediction is going to be. So dynamically, before we get the final yield, at intermediate stages, whether the growth is happening in the right direction or not. Is there any issue associated with the growth of the crop? All that can be predicted, okay? And if there are some disease or weed that can be detected, crop regeneration system, selective breeding systems, all that can be added. Water management is possible, livestock management, okay? So these are all some of the application areas where ML can be used. So when we talk about the different ML models which people have already tried for agricultural application, as I said, people have tried a lot of regression models, lot of clustering or classification model, Bayesian models, artificial neural network. So these are some of listed out some of the application areas where these models have been tried. So any kind of prediction that you wanted to do, you can use regression model. Any kind of diagnosis you wanted to do, you can do a clustering model. And Bayesian models can also be used for prediction purposes. And then ANN can be used for artificial neural network, can also be used for prediction or for classification. So I've taken out some of the specific, okay, specific applications, okay. Out of the many applications which are listed, I've taken out some specific applications where AI has been used. So this again I've taken from this particular resource. I've listed out the reference from where I've taken. So this is basically for leaf disease identification that used artificial neural network. So what is it we see? As we have seen in the CNN case, the image of the leaf, in this case it is a cotton leaf, that image is going to be given as an input. You have got a deep network which can be a CNN or artificial neural network. Finally, you wanted to say whether the leaf is healthy or it is going to be diseased. Okay. So initially, when you wanted to develop this system, you need to have a lot of images of the leaves, and a farmer has to say whether the leaf is healthy or a leaf is diseased one. So that means we need farmers' expertise. What kind of data is used? The data are nothing but images of the leaves. Okay. How many images we need? So we need large number of images. Okay. And each of the image you need an experienced farmer who can say whether the leaf is healthy or is diseased. So that means we need to label them. So if you have got input image versus a corresponding label, you can develop a system which can predict whether the leaf is healthy or it is going to be diseased. So this is a paper where they have done that. They have used a deep neural network for identifying the disease. Okay, and these are all the different stages which are involved in AI development. Okay, so like we see, images are collected on the right hand side. You see, images are collected, and those images, some kind of pre-processing is required. What are all the pre-processing you can do? You can do some kind of enhancement. You can remove the noises which are present. You can undertake the different portions of the images, and if the data are limited in number, you can augment the data. Finally, you will come across a final data set which can be used for training and for testing purpose. So you will split the data into training set and testing set. The training data you will use it for model training, for training the model, and then the test data, once a model is trained, you will periodically apply the test data and see whether the prediction is good or not. If the prediction is not good, you will continue with the model training. Okay. So here you see the deep neural network getting used for disease diagnosis, again the CNN kind of the network. So we have got a convolution layer, cooling layer, convolution layer, cooling layer, and finally fully connected layer. So that means automatically a CNN network can give you information regarding whether the particular leaf is diseased or this is a healthy one. So this development will not take much of our time. So this is the way in this particular paper the author has done. What they have done is they have basically used a transfer learning approach. In machine learning, the recent or very improved development is the transfer learning, where you see the ImageNet data set has got so many images available. So they pre-train the network. So there's a pre-trained network. From the pre-trained network, you freeze the top layers and try to extract the features using the pre-trained network. Those extracted features can be used for the last fully connected layer and train it only the fully connected layer alone, so that you can identify the specific diseases with which the leaf can be affected. So we see it is not only binary classifier whether disease or healthy, you can also specify specific disease with which the leaf is affected. Again, for this also you need a formal support who has to say which disease it has been affected. So that means we need an expert knowledge. So if the farmer can label and give us, this development is not going to take much of our time. So we need basically a big data set, and that should be a labeled data set labeled by a farmer. So with that you can identify whether a leaf is affected or not, what kind of disease it has been affected. Okay. And another paper where they have used this AI for crop prediction or yield prediction. Okay. So the different inputs, as I said, for all this, whatever data which is already available, from that we wanted to make some meaningful inference. Okay. So like how do the farmer decide which plant to plant in the field? They take a lot of information. Like you see this NPK, which is nitrogen, phosphorus and potassium content. And then you also see the temperature, the pH value, and what is the average rainfall in the area, the soil quality, humidity. All these are taken as an input. Okay. And from all this input, you wanted to try the different AI models, data models you wanted to try, and you wanted to recommend what is suited for the present condition of the soil, present condition, environmental conditions, present condition of the soil, what is the crop that is recommended. So these are all the varieties of crops which has been recommended in this particular work, in this particular paper. So like this, based on what information is available with the farmer, the same information is also given to the AI system, and whatever decision which is taken by the farmer, the same decision we wanted it to be taken by the AI tool also. So we are trying to mimic the expertise of the experienced farmer in the form of an AI tool, which can help even an inexperienced farmer. It will help. Okay. Yeah. So what are all the future scope where this AI can play a big role in agriculture applications? Okay. Can you just move it slightly up? I think it got cut, is it not? Okay. So like already reported, like the deep networks and all people have already used for AI application. So what is the future scope? It's going to be like people now started using what is called as deep learning and federated learning. Okay. Federated learning is going to be distributed learning. As I said, in agricultural application, there is an uncertainty with respect to different regions. So whatever model you develop for one region, geographical region, will not work for the other geographical region. So you need to fine tune the model. Whatever model you have, that can be fine tuned for different geographical region. So this federated learning talks about developing the models for different geographical regions and then merging them, aggregating them. So that is again one of the future scope. A lot of people are working in that. And again, edge computing. Now, whatever algorithm that we are developing here, we wanted it to be run in an edge device. We wanted AI algorithm to, so people talk about embedded AI or AI getting embedded into the small, even in the mobile phone. Okay, so you can come up with some kind of a user-friendly apps. Okay, user-friendly apps, user-friendly web platforms where you can run your AI algorithm and the farmer can directly get some kind of a guidance, even from a remote location. And people are trying to come up with a digital twin not only for the farmer, digital twin for the field also people are thinking about. So that's a very interesting area. So some of you wanted to take up some projects, you can also think of developing a project related to this particular area, where we wanted to develop some kind of a virtual replica of the field or the firms itself. Okay, so that will allow the farmer to simulate various scenarios. Okay, instead of going to the real field, cultivating it, in the virtual field itself, the farmer can simulate various scenarios such as what kind of crop, water usages, different weather conditions. This will help the farmer to predict what is going to be the outcome and optimize strategy before implementing it in the real field. So before implementing it in the real agriculture field, if you can have a simulated platform where whatever is happening in the real field that can be simulated, so you will know, you can predict the final outcome even before it is implemented in the real field. So that's also another interesting area. And a lot of robotics and drone technology is getting used for agriculture applications. So next generation, lot of robots and in foreign countries you will see a lot of robots already being used for agriculture applications. Okay, and seeding systems, small seeding systems. Okay, that also you can think about doing it. And climate dependent smart agriculture. Okay, so like here all the extreme weather conditions, whatever predictions we do on the climate, adapting to that practices for the ongoing climate changes. So we can recommend, so if it's going to be a water crisis or a drought, accordingly you can recommend what kind of crop can be recommended so that you will get a high yield as an output. Okay. And finally, by using the AI as a tool, we can optimize all the resource utilizations. Okay. So that means even like here, the forum says that using AI, 60% you can reduce the pesticide use. Okay, so you can make appropriate predictions, and 60% you will be able to reduce on the pesticides usage. Okay, so these are all the future directions where people are working, trying to explore AI for an agriculture application. Okay, so with that, I think there is 5 or 10 minutes time. If there are some questions, I'm happy to answer. Okay, thank you.
Participants are open to ask questions if you have any. Thank you, ma'am, for gracing this occasion with your valuable insights. Now I request Sarveshwari to give the introduction for the next speaker.